All right, here's the much anticipated sequel to 9.4a. So 9.4b is on multiplying and simplifying these radical expressions. Now, one thing to notice before we get started on any kind of examples, with addition and subtraction, you need like terms. For multiplication and division, you do not need like terms to multiply, right? It's just like how you can multiply 3x times 4y and get 12xy. To add them, you do need like terms. So you do not need like terms to multiply. So that's really, really important. So what we're going to do with these is we're really going to make use of these exponent rules a lot. So it's going to be kind of, buried in here, but that's the basis of how all this is going to go down. Now, for this one, first example here, multiply and simplify. You don't even have to do this by hand. You can use your calculator because there's no variables. So you can just take, root 3 times root 12. Now, if you were to do this by hand, you can combine these two. So with multiplication, we can pull these together into one radical and multiply 3 times 12, and we get 36, and the square root of 36 is just 6. What we were doing in the last section, and in previous, 9.4a, and then in previous sections, we would take something like multiplication and split it into two radicals. Now we're taking these and we're pulling them together in an attempt to simplify them. Now again, you can just use your calculator from the get-go. You can just do the square root of 3. Now be careful. Don't go ahead and hit times because look, that times is under that radical. So let's not do that. Instead, let's hit the right arrow, get out from under that radical. Times, bring in a new radical. There's root 12. Let me get 6. Okay. This one doesn't have any variables to it as well, so let's see what happens if we use the calculator on this one. So we have root 5, so use the right arrow to get out from under that radical, parentheses, root 5, get out from under that radical, subtraction, root 10, get out from under that radical, and let's see what we get. Negative 5 root 2 plus 5. Well. Look at that. Now wait a minute, you may be like, that's not the same thing. It is. The calculator always writes it to where like the root is first and then the constant is second. But look, same thing, right? Positive 5, negative 5 root 2, look, minus 5 root 2. Same answer. Even Hawks will say it's the same answer. If you want to see how this goes, how this is all going to go down, this root 5 gets distributed. Okay? So root 5 times this root 5, and then root 5 times that root 10. Those combine into root 25, which simplifies to just be 5. These simplify to be root 50, which you then have to simplify by splitting it into two factors, one of which is a perfect square. You don't have to do that stuff by hand, okay? You can just use the calculator for that. Oop. I started it right there. Here, let me. Zoop. You can use the calculator in the whole thing. I don't mean to imply that it's like, oh, you gotta get to there. No, whole thing. Because there's no variables. But I wanted to show you what was happening because as soon as we bring variables into it, this is no longer helpful. So for C, if we were to distribute this out, you can say this is like FOIL. Let's see. Got a feeling you can use the calculator on this one as well. So root 6, right arrow to get out from under it, minus root 8, right arrow to get out from under it, times root 6 plus root 8 minus 2. So you can use the calculator on this one as well. There's no variables to it. But I went ahead and showed you all the work because as soon as we throw variables into it, it may not make as much sense. But here's what's happening. This is FOIL, or the distributive property. So that's root 6 times root 6, root 6 times root 8, minus root 8 times root 6, minus root 8 times positive root 8. So here's all the behind the scenes stuff. Now with this one, you have that squared in there. Be really careful. Do not distribute an exponent. Do not say that's going to be root 5 squared minus 3 squared. You cannot do that. You cannot distribute an exponent across addition or subtraction. Instead, what you have to do is know that squared means that thing times itself. Now again, just like the last example, we don't have to do all that stuff out by hand. I'm just showing you how it all would play out, but we can just type this in exactly as it looks. So we get root 5 minus 3, and then we're just going to put that quantity squared up there. Look at that. So it is the same answer. So look, the 14 is positive, and then that 6 root 5, see how that's negative? So I got that subtraction, 6 root 5, same answer. Even in Hawks, if you put that answer in, Hawks is even going to say, yep, that's great. You're awesome. Okay, so now we're going to move away from the ones where the calculator is going to be as helpful. Now we have ones that have a whole bunch of variables to them. So remember how I said that this squared means this thing times itself. Do not distribute that square. Do not do that. You can't. If you could, I would. I am not making this harder on you. I swear to you. All right? If we could distribute, we would. We cannot. Instead, we have to just take the squared as saying this thing times itself, and then FOIL or distribute, whichever way you want to say it. All right, so let's distribute this thing out. Root x times root x. Root x times 4. 4 times root x, and then 4 times 4. Now you can see right here, when I did root x times 4, that I just wrote the 4 first. That's because if I wrote root x times 4, if you get just a little bit messy with it, you might accidentally make it look like that 4 is under that radical. So if something's not under the radical in multiplication here, I will just bring it out front. So just to let you know why I chose to do that. Now, let's simplify this stuff. So those two simplify to be the square root of x squared, which is just x, right? The square root and the square undo each other. They're inverse functions. That's just 4 root x. That's 4 root x. That's 4 times 4, which is 16. Now these two are like terms. They have the same root x part, so I can add 4 plus 4 and get 8. So that simplified to be x. That was 8 root x. That's 16. None of these are like terms, so there's nothing else I can do to simplify them. Right? So remember, the squared means this thing repeated. So it's that thing times itself, and then it's just the distributive property. Right here, instead of writing root x times 4, I wrote the 4 first. I mean, if you need some, technological, terminology here, that's the commutative property of multiplication. But yeah, I just put the 4 first so that there was no confusion as to where that 4 was. Was it under the radical or was it not under the radical? It's not. All right, so let's do another one here. I would advise you to pause the video here and see if you can distribute this out and then combine the like terms. So pause the video and try this one ahead of me. Don't just watch me do it. You can participate too. So. All right, so if we distribute this out, we're going to get 2 root x times 3 root x, 2 root x times 2, minus 6 times 3 root x, and then minus 6 times 2. You can't use your calculator for this. I know you might be thinking, oh, well, I'll just use the calculator because it has an x button. No, no, no. That x button is only going to replace x with whatever number is stored in there for it. It doesn't do variables like that. So you guys know I'm going to show you how to use the calculator if it can be done. I'm not holding back on you, I promise. So combining these, 2 times 3 is 6. Root x times root x is root x squared. So square root of x squared, remember the square root and the squared inverse functions, they undo each other. So that's just going to give you x. Here I'm going to get 4 root x. Here I get 18 root x. Bring down that sign. 6 times 2 is 12. These are like terms. So this came down here. That 12 came down. These two combine. Plus 4 minus 18 is minus 14. None of these are like terms, so that's as simplified as it can get. So this is very similar to chapter 5, where we multiplied polynomials out, but just now you have to remember those radical rules. So here's another one. Now we're going to bring in another variable, so pause the video and try to work ahead of me and see what you can do with this one. So distributing this out, I'm going to get root x times root x, and then root x times minus 4. Again, I put the 4 first. Root y times root x, root y minus 4. Again, I put that coefficient there ahead of the square root. All right, so simplifying these out, that's going to be the square root of x squared minus 4 root x. And look, these two I can combine, they're multiplication, so I can combine those into one radical. This comes down. This square root and this squared undo each other. And we end up with this. None of these are like terms, right? That's the square root of x, that's the square root of xy, that's the square root of y. None of those are like terms, so that's the best you can do. And that throws a lot of students off. You know, they look at this and they're like, surely there's something else I could do to simplify this. Nope, that's as good as it's going to get. All right, let's look at this next one. So pause the video, try to work ahead of me. Don't just watch and assume that you're going to absorb this. You do actually have to practice with me. Okay, you can't just watch and learn. I wish you could, but it'd be like, you know, watching the Olympics and being like, oh yeah, I can totally do that gymnastics stuff. No. That's not how it works. That's not how math works either, unfortunately. So pause the video, try to work ahead of me. All right, so here's the distributive property. 3 root y times root y. 3 root y times root 2x. And you can see how I'm trying to group these together. Right, so it's this distributed and then this root 2x distributed. And then multiplying each of these pairs together. This is going to give me that square root of y squared. These two, that's going to be the 3 on the outside and then the 2xy on the inside of the radical. Here, 2xy on the inside of the radical. Now, you might be like, where did that 1 come from? Well, there was no coefficient there, so I just put that understood 1 there. And then these two, 4x squared. These two end up being like terms. This square root of a squared, those two undo each other. So I get 3y. These two combine into 4 root 2xy. Oh, and then this guy. This was looking all sweet and innocent over here, but wait, that can be split apart into the square root of 4 and the square root of x squared, both of which are going to simplify further. Right? The square root of 4 simplifies to just be 2, and then that square root of x squared, that square root and that squared undo each other, and we just get x out of it. None of these are like terms, so that's as simplified as it's going to get. One more, and that'll finish up 9.4b for us. This one, again, with the distributing. So I'm going to distribute the 5 root y times both of these. Here's my 5 root y. So there's 5 root y and 5 root y. And then I'm going to multiply each of these pairs together to simplify them further. That'll be 5 times 3, which is 15, and then those square roots there, that's going to combine into xy. Now you may ask, why isn't it yx? I guess because I just wrote it in alphabetical order. You can put yx, it's the same thing. And then over here, 5 times 2 is 10, y times y is y squared. We get that square root and that squared undo each other. So this stuff right here just turns into y. These are not like terms, so they can't be combined. And there's nothing else that's going to simplify, like under these radicals. So, all right, so examples 2 and 3 that I just did demonstrate 9.4b. So remember, there are 3 videos for this section. There's a video for 9.4a, there's a video for 9.4b, and then there's one more for 9.4c. So make sure you watch all 3 of the videos for this section.